where he's an associate professor of economics, telling us about improving refugee resettlement.
Thank you so much for having me. Great pleasure. I should, as the economist, should show up earlier so that I can figure out how to get the text to work. So this is a joint work with a lot of people. I think I haven't missed anybody out, but there's some wonderful people in the US, in Sweden, in England. And so I'll show you a kind of a mishmash of different projects that I've done with a bunch of them. So what I want to talk about is a problem that I've been working for about 6 years. And I think this is kind of what qualifies me to even come to this amazing workshop, because I sort of, it's a societal problem. It's a huge societal problem, and that is how we deal with a crisis of refugees. There's more refugees now than there have been since the Second World War. And rich countries like the US often bring refugees to the US. And what we've been thinking about is how to help them relocate, where should they move, and how can we sort of help them get on with their lives in the best possible way. So it's going to be a three-part talk. I'm going to tell you about 3 projects. The first one's going to be, it's a project that's sort of completed in a way, and it's going to be about a piece of software we built that helped a US resettlement agency move refugees. It's called Annie. So I'll tell you about that. It's a simple static optimization problem, but it'll kind of help me set up the problem a little bit. And then we, I think the correct word is we retired it. I think that's what you do with software, right? And then we created a dynamic optimization problem. So it's called Annie 2.0. And I'll tell you a bit about how that works. And then the final thing, and this is the thing I'm most excited about because it's happening right now. We built the first ever, and this is the first time it gets presented. So this is the treat, this is the bonus, the dessert. It's going to be the first ever system that uses refugees' preferences to match them to areas around the US. And I've been thinking about this problem for 6 years. I can finally say that we have built a version of this, and it's very exciting. This piece of software is called Ruth, and it is allowing the agency to match Ukrainians who have been displaced by this terrible war to the US. So there'll be no model, no lit review, no equations. This talk's just going to be kind of casual in general. I've never given a talk like this before, so it's merely kind of my way of trying to put all of this together. So please interrupt me at any point. I'd be happy to stop and clarify anything that's not clear. I'm lying, actually. I'm going to give you a lit review since we're in Berkeley, because there's an amazing person working on these problems in Berkeley who's just moved to Berkeley, and his name is Kirk. So if you find this person on campus, he's fantastic, and his work inspired a lot of my work, and so I'm very grateful to him. Okay, so let me just tell you a bit about refugee resettlement. It's a political thing. Ultimately, in the US, how many refugees are admitted gets decided by the president. Okay, that's a kind of first order approximation. So the president just signs an executive order, and that caps the number of refugees that can be admitted. So when President Biden was elected, he promised that he would admit 125,000 refugees in a year, which is quite a few. It's not a kind of particularly huge number if we compare it to the numbers that were coming in during the Obama administration, but 80 to 90,000 people per year. Now, after that, of course, you, as in the American public, elected a different president, and that president reduced the number of refugees to 15,000 per year, which was quite unfortunate given that we were working on refugee resettlement. Now, just to give you an idea of how politically divisive this is, President Biden announces this around February 2021. About a month later, it turns out that actually he doesn't want to have this number. He actually wants 15,000. And remember, that's exactly the number that Trump had kept in his last year. Of course, Biden, being a Democrat president, really upset his caucus, and people complained. And so the number then went back up to 62,500. But this is just to say that it's a divisive political issue. It's the way that these numbers are set is extremely capricious, and it comes from this sort of, negotiation that is going on with everything else that matters. So as Moon said in the very first talk, vote. If you care about this, vote. Vote for whoever your favorite candidate is, but who you elect as a president will matter for how many refugees come to this country. And where do they go? Well, they go everywhere, except I think instead of Wyoming, it's not very shaded in a very dark color, but they go everywhere, all over the country. So darker states admit more refugees, not per capita, but in total. And so New York State and Florida, Texas, California, of course, take the most refugees by being the populous and the richest states. But refugees go everywhere in the US. And so let me tell you sort of how we think about this problem in a kind of step-by-step way. Yeah,
so
right.
The number you showed us is the number of arrivals or the number of admitted cases?
Perfect. So the cap is the max. Sorry?
Can you repeat the question?
Oh, sorry. So Rad's question was the number that I showed you, which is 62,500, is that the number that was actually admitted? So that's a great question. We're going to come back to it later on. That's the cap. Okay. So how many refugees arrive is how many refugees arrive. It can't exceed that number, but could be below that number. Part of the justification for why Biden said, actually, we're going to keep the number at 15,000 is because after the Trump era, the infrastructure for resettlement was completely destroyed. And so they really couldn't actually have admitted 125,000 people in that first year. And so, but keeping it at 15 was just kind of really insulting. And so they went halfway, as you saw. Okay. So that was the cap. But thanks, Red, for a great question. Okay. So how does resettlement work? It's going to give you an idea of a step-by-step process. So this is managed by a bunch of agencies, different departments in the US, Department of Homeland Security in particular. And so thousands of people arrive. And the Department of Homeland Security and the State Department, they decentralize these processes to 9 resettlement agencies. And so I work with one of them. And the resettlement agencies are responsible for finding placement for the refugees around the country. And the way they do it is by having a network of what they call affiliates. So I work with an agency that was historically Jewish. They used to resettle Jews from Eastern Europe to America in the late 20th century. Now they resettle whoever comes to the US, but they have a network of synagogues around the country in particular. So these affiliates are a bit like synagogues, and members of the synagogue might donate money to help the synagogue resettle the people. Now, so why is this problem interesting? The reason why this problem is interesting from a kind of optimization perspective is that there is a lot of good empirical evidence, causal empirical evidence, that shows that the initial match between a refugee and a local area really matters for people's lifetime outcomes. And that is a non-trivial point. And the reason is that once a refugee comes to the US, they're free to go anywhere they want. They get kind of the rough processes, they get a 5-year visa. After 5 years, they can apply for a green card. They're here to stay, but they can go anywhere. And so it is actually quite surprising that the initial place where the refugee is relocated matters for their outcome. The reason why it happens is because often people don't move. And so they actually end up staying in the community for a long time. Because the match between the community and the refugee can dramatically affect how well people do. Now, the thing to then realize is like the objective, if you like, right? So you care how well people do. The constrained bit is that the government approves how many refugees at a very local level one is allowed to have. So the resettlement agency goes back to the State Department and says, we're going to relocate 25 people to Worcester, Massachusetts, and 75 people to Palo Alto, California, and whatever. And these numbers are binding. You really cannot exceed them once they have been approved. So this capacity is limited. It's not limited in the literal sense. Of course, if you wanted to, you could have doubled all of these. These are still tiny numbers of people in principle, but they are capped by law. And in particular, once the capacity is fixed, let's say the synagogue that is helping doing resettlement, they sort of work their resource around this number. So you can't just scale up like that, right? You actually need to give people some warning about how many people come in. So these things are limited. And so the question is, how do you try to set up a sensible objective? And as I'll show you, that's actually been given to us by the US government, and how to optimize or improve the outcomes of refugees within the given capacities. Okay? The interesting part of this, and this is one of the things that is kind of cool about being an academic and working with an NGO, is that you need to, you can't just tell the agency where the refugees need to go, because ultimately, legally, the agency is responsible for every placement that gets made. So on the one hand, you want to say, hey, here is my clever system that's going to optimize where everybody goes. But on the other hand, you actually want to give a lot of discretion to the agency to be able to tweak things, right? And so we'll kind of carefully tread that issue. Okay, any questions? Yeah.
One quick question about the capacity, because there are multiple agencies that are resettling. So that capacity, like on a government level, is it for all of them or for each?
So it's for agency affiliate specific, right? So you might as well just think about specific agency and their specific affiliate. That affiliate will have the capacity, right? So it's not like there's a capacity for everybody in Pittsburgh.
Right.
There's a capacity for this affiliate in Pittsburgh, and there's a capacity for this other affiliate in Pittsburgh, and the agencies do the relocation independently.
I see that.
Okay.
Good.
Now it's perfectly possible that where actually refugees get housed this might be exactly the same place. So this is, I don't think the system is particularly well thought through, but it's exactly right. But thanks for clarifying. Okay. So as you will see in a moment, everything I will show you could be done if we just the systems that we have here will just resettle all the refugees in the US. So there's nothing wrong with that. Just so happens, it's difficult to kind of start collaborations with agencies one by one. So we're working with one specific agency. Okay, so this is a paper about the kind of the first step of this, and kind of roughly show you how the it's really quite simple how the Annie Moore, this optimization system for refugees works. So here is my my one slide that I show to agencies. Remember, this is not what I usually show to academics. So it's going to use words like state of the art. And then I'll point out which bits are actually state of the art. Of course, this is being recorded. I need to make sure that my colleagues in the agency don't suddenly think I've been fooling them. But let me just show you how what the idea is. So we have employment prospects, right? We've got 2 bits of data. We've got data from a US government system called IRIS. So we can observe who has been resettled where over, say, the last decade, and whether or not they got a job within 90 days of arrival. That's going to be our objective. It's a binary variable. Have you got a job within 90 days of arrival? Now, how much you get paid, the thing that we care about, sorry, not the thing that we care about, the thing that the US government cares about is whether or not a refugee has got a job within 90 days of arriving to the US. Okay, so we look at that, and then we put in advanced. You see, that's the first page. Machine learning can try and estimate exactly what the counterfactual. So what we observe, of course, is a particular refugee has arrived in a particular area. So we say, okay, well, given your characteristics, if you had arrived somewhere else, what would have been your employment chances? Okay, so we estimate that. There's a model that we estimate, and this gives us a counterfactual for every possible refugees, given their observable characteristics. And there's reasons, it turns out, and Kirk's work is in part has been instrumental in kind of showing that it's actually possible to do this on past US data because and actually estimate these things carefully and causally. You actually identify this from the data. So we've got these counterfactuals, and then what do we add to this is basically a bunch of constraints about who can go where. So I've already told you about the capacity constraints, but there's a lot more than that. And these are basically constraints about what kind of refugee can go where. Maybe kind of a simple example to think about is match on language. So if a particular refugee does not speak, or a family does not speak English, it's very desirable that there is somebody in the affiliate that can speak their language, right? And so we want to make sure that somebody only speaks Arabic. We send them to a location where there is somebody who can speak Arabic. And so this is a kind of thing that we can observe for our affiliates, and we can make sure that this is satisfied. So there's a bunch of constraints like that. It's another pitch, state of the art. Good old open source software can actually solve these things. So we put these 2 things together. This turns out to be a multi-dimensional knapsack problem. Why is it knapsack problem? Because refugees come in families. Actually, it turns out to matter quite a bit. Some affiliates cannot take in too many refugees. Some families are actually quite big, so the kind of knapsackness bit comes in. But anyway, this is all easily solvable. You have a little matching engine. We even have little gears. They move around in the software, and you get your best overall employment outcome for all the resettled refugees. Okay, I'll be kind of a bit clear about exactly what that means. So the thing I should say is that the matches are suggested. Cool.
Are you deciding subject? Are you deciding subject to these constraints who to admit, or to give you a list of admits?
Great question. So sorry, everyone heard your question. That's good. So no, so the refugees are given to us. So they're admitted really, there's a very long process. Typically, these people have been in a refugee camp for a very long time. They apply to come to the US. They go through security clearance. There's all sorts of checks that happen on them. At some point, they get admitted. There is also a little pre-process, which is which agency do they end up with? You can think about this as basically being a lottery, okay, just kind of a uniform lottery. So an agency just gets a set of refugees that are then responsible for relocating, okay? But thank you for clarifying. Anything else? But hit it, and then Dan.
So you mentioned the objective is overall employment
Yes.
outcomes. So, and you mentioned also there are some big families, right?
Yeah.
So how should we think about employment for like a whole family?
Yeah, so we just
Like-
added up the prediction for each individual family, remember. It's just kind of linear, and we have some sort of checks that we do where we say, okay, it might actually be good that if we treated a family weight as the maximum for of an adult, so you can think about it in different ways. But if your probability of employment is 0.7 and Kevin's probability of employment is 0.3, I will give that family a weight of 1. Just gonna add them up.
Does it mean that then, let's say, you would prefer to match 3 singles to California that has a very large like employment probability compared to like a family
Correct.
of
I'll come back to
that-
this point. Okay, so hold that thought. That's exactly the right. This is the problem with people who do too much optimization. They
Yeah,
see the
yeah.
solution before you even set up the problem. But you're absolutely right. That's exactly right. Daniel? I'm getting anything past you.
With respect to matches being suggestive,
Yeah.
do you then also provide options? Like if you make basically you have your optimal match, you're saying this
Yeah.
is what the best option would
I'll
be?
show you how it looks so you
Okay.
can see it exactly. Yeah. So I'll show you exactly how it looks. Yeah, right.
So one question is, do you consider like joint employment prospects for refugees? Like, for example, I guess from your answer to that, it seems to just like add up the.
We just add them up. They could be done in a more sophisticated way. So if like your partner was more likely to get a job, maybe you're substituting, maybe you're complementing. We're actually, this is a bit more, it's actually quite too hard to get it out of the data because you don't get a lot of, there's not enough variation for kind of family composition in the data. So it's quite hard to do.
Positive externality if you send people especially the same language to the same affiliate, or
So what I'm not going to tell you anything about is what makes affiliates good at giving particular refugees jobs. You're going to treat them as a kind of black box. So I'm not even going to care about what these characteristics of the affiliates are. It's a good question. Anecdotally, and honestly, talk to any refugee that's come to the US, the community aspect seems to really matter. So people tend to really find it easier to find jobs if they've been resettled to a community from their country. But this is anecdotal. I don't have kind of my own evidence on that. But thanks for asking. Okay, can I keep going? Okay, great. So this is what it looks like. This was a response to Daniel's question. You get this kind of cool little dashboard. This was all built by, I should advertise, by one student. Okay, one student built this entire freaking interface. It's really amazing. So here is like this blue box is an affiliate. So here you see it says NC Charlotte. So this is Charlotte in North Carolina. And these green boxes are the refugee families. And so what you can do is you can drag one of these boxes and you can put it somewhere else. You can put it in here and it will tell you whether you're violating any of the constraints or indeed what is the loss in your objective function. So at the top, you've got the objective function. So if you match refugees like this, you'll get 26.37. It's kind of deceptively accurate, right? Or sorry, it's deceptively precise, right? And you can move them around, and you will see how it changes the objective. Okay, so this is about the discretion part. But by and large, what we found is that very little rematching actually gets done. So in terms of performance, allow me to go a little bit quicker. I will just give you an idea. The area under the curve is about 80%. You might say, is this good or bad? It is what it is. And then we try different scenarios. So we kind of, when we test the software, kind of look at what really seems to matter. So I'll just kind of give you a very quick overview. We can get the employment rate from about 30% to about 40% by doing optimization. So this is a 10 percentage points difference. It's a 30% difference in terms of employment. So this is massive, I think. And then you might put in a bunch. So one of the things that happens is back to Vahita's question. One of the things that happens if you just kind of run the model with the constraints put in, is that a lot of what the model tells us is a linear objective. The model tells you to put a lot of single unit families to places that are really good at giving people jobs. And in our case, it's a place like Pittsburgh, for example. As it happens, it's a place that is really good at giving people all kind of refugee jobs. And the model basically says, put in all the single people who arrive. These are typically men in our data, in this specific data, it's men. And so you might say, this is not great, because suddenly we haven't got a balance, kind of a nice mix of families and single folks and so on, right? So what you can do is you can put in a bunch of constraints. Okay, let's actually make sure that the average family size is say about 2, something like that, right? And nevertheless, we still get a massive gain in employment. It's not as big, but it's actually not so bad. You can obviously crush it if you put the constraint in high enough, you end up getting infeasibility, but actually even with a reasonable constraint on what the average family size needs to be, you can still get huge employment gains. So this is the first paper we published about this. And I hope this kind of frames roughly what the problem is. Okay. Now here I should have said that the model gets run once every couple of weeks, and the quota, the capacity for a particular affiliate, is over a course of the whole year. And everybody in this room, or probably almost everybody in this room, might think, okay, this is not a very good way of doing this, right? You can't just kind of statically match people over the course of the year and hope they will give you a really good objective by the end, okay? So then we wrote a second paper, which is about dynamic placement optimization. And the idea is very straightforward, right? So if what I just said wasn't completely intuitive, let me give you a very simple example. So suppose we have two affiliates, Austin and Boston, okay? Neither of them are in our data, okay? So these are made up. We've got 3 families, and the capacity is 5. And the green means green edge means high employment probabilities, red edge means low employment probabilities, and the colors in between is something intermediate. So if you had a static matching problem, you just had all the refugees arriving at once, right, which you don't, you could just kind of solve this and match the families in the best possible way. Yeah, let's just do this with, run a kind of a simple knapsack algorithm here, and then it will maximize. But you need to have everybody here. Now, of course, families arrive over time, and you don't get as much warning as you would like. In principle, it could be the case that the US government would just say, here are all the people that we're going to admit over the next year. But you get about sort of 3 months in terms of warning, if you like. So what would happen in this case, if these families arrive first, you would look at these guys and you would think, okay, well, let's kind of let's do as well as we possibly can for these first arriving families. So what we're going to do, we're going to match them to Austin. And you can see, so now I've only got 1 unit of capacity left. So the best match for these families are to put both of them into Austin. Of course, when the next family comes, now I don't have enough space in Austin to match this family anymore. And so what am I going to do? Then I'm left with taking them to Boston. Of course, that was suboptimal. So if I'd known that Austin was this great place that could have let me match this family, I would have held this capacity back and maybe matched this person to Boston in the first place. And that would have been better, as you saw from the static problem. So the question is this really a problem inside on our data? And the answer is yes, okay? So if you ran the following counterfactual, said, okay, imagine I knew exactly who was coming in a given year and I could match them perfectly. That's what's called optimal hindsight, yeah? So that's the blue line. And then suppose you did the greedy algorithm we just talked about. You just matched people myopically every week. How would the quality of the matches vary over time? So what I have here on the y-axis is basically, if you like, the matching score. Just think about this as like the employment probability of a family over time, of a family that gets matched. So the beginning, what you can see is that the greedy algorithm is getting a higher score. Why is that? Because it's using up the capacity in these really good localities early on, because people are coming in and thinking, okay, great, just going to stick them into these really good places. You're getting higher employment than the optimal hindsight. But eventually, it starts underperforming. And so what you want to do is you're going to think, okay, well, this is a good area. So you take the integral here, and then you compare on the underperforming part, and you can see that obviously the greedy algorithm is going to underperform. Okay, so it's the difference in between these two areas, and what we find, you get a loss of about 10% in efficiency if you just greedily optimize. Now, of course, the trouble is that we don't know, we can't do optimal hindsight because we're not God, right? So God knows who is coming, but we don't. And so what we want to do is we want to make sure that we're using up capacity in the sort of most even possible way. So I'm going to come back to this idea of a price capacity, but kind of intuitively think about it in the following way. We've got some capacity in, that we know we're going to have left, and some places are just going to look more desirable. And so in a way, they have a higher price, right? As we're going to take that price into account. They're in higher demand because they're desirable locations for resettlement. And we've got to take that higher demand into account. Okay, so I'll show you how we do it. So the idea of price and capacity. So when you place a particular refugee family into an affiliate, there's two things that happen. Well, one, it increases employment. That's the obvious thing. But the other thing it's doing is that it's taking away somebody else's slot. And what the myopic algorithm doesn't do is it doesn't take that thing into account. It doesn't take into account opportunity cost. Okay, so put it into all of these languages, and this is language because it really makes sense to me as an economist. But I think this is, kind of, if you like thinking about it in prices, I think actually it's really quite nice. So the idea is the following. What we're going to do, we're going to myopically maximize this thing minus this thing, right? If you like, the benefit minus the cost, okay? And so how do we estimate this opportunity cost? We're going to look at the data. We're going to simulate the trajectory of arrivals, sampling from the previous arrivals. And we're going to project what kind of people are going to arrive through the rest of the year. And this turns out to be a really good prediction, this past 6 months data. So obviously, the example you might have in your head is, what if there's another war in Syria that starts? Well, of course, then the composition of refugees might drastically change. But if the war's already started after 6 months, your prediction of who's arriving in the US is going to be pretty good, okay? So indeed, these kind of, you have to be careful about these massive changes, but they don't actually occur that often, okay? Daniel.
Question out of curiosity about the distinctions between different countries in the world. So like, if I imagine Ukrainian refugees in Germany, it's very much like those people came earlier this year by, like they came immediately. And I don't know to what extent, or I'm curious to what extent, if you're thinking about Syrian refugees in the US, only come to the US after several stops in between, in refugee camps, in other countries. Would you basically be able to use information, because the journey is so much longer, that there's actually better arrival information than what you just have by drawing?
So there's two reasons why you should really not use any of this for the German case. One is that the composition is going to be completely different. These are people, you know, it's a sample of people who are able to travel across Europe. That's number one. But on a more basic level, US has very regularized refugee resettlement process, right? By being sort of, by having two oceans on either side, that essentially prevents the only migration, irregular migration that happens is on the southern border, right? And so every single person in my data set came by plane, right? And so they were admitted, and that's not what happened in Germany. So a lot of the things that happened in Germany early on was that people were kind of choosing where exactly they were going to go themselves. And the German government did not kind of fully control this process. Now kind of they're trying to sort of change things, but having taken the sort of the initial arrivals as given.
But for the people who come by plane, don't you know 6 months in advance that they're like?
Not as much as 6 months in advance. No, that's the problem. Yeah. So we give them much less warning than 6 months in advance. Another question? No. Later. Cool. Oh,
I can ask.
Yeah. Hi.
So it looks to me, hello. Yeah, so thank you. So it looks to me like if I just optimize this objective function, that I will get a job in the next 90 days. I mean, some arrivals, let's say I don't speak English, has a less probability.
Yes.
And if I just optimize this objective function, they are not important for my objective function.
You're absolutely right.
So do you re-weight people's?
I don't like this objective. I can say this on record, but the objective is given to the agencies by, if I remember correctly, the US Senate, actually. There's a rule or a law that basically says, we want you to maximize this objective. So what they are told to maximize in order to be able to get funding for these refugees come with a little bit of funding for that first 90 days. To be able to sustain that funding, they need to maximize the objective. And we all here understand that a binary yes or no employment after 90 days cannot be a good thing for human welfare. That can't be good, but it is what it is. And on the one hand, fortunately, we can then take this immediately to application. On the one hand, I don't know how much more harm than good we're really doing here. But for the objective that we've been given, we can definitely improve. Thank you. Yeah, Will.
Hi, Alex. Hi. So related to Ola's question, I'm wondering, do you have a sense of how often your engine can make sort of like Pareto improvements where both people are better off? Like in the example you gave, right? It was like better off overall, but it was worse off for sort of the most capable person.
So for the static case, I can tell you the answer. Something like, so given the matches we make in the static case, about 95% of refugees have a higher probability of getting employment under our system. It's almost a Pareto improvement, which is really good. So you really need to check that, right? Are we doing this at the expense of others? So for sure, the thing that really happens here is when you arrive in the course of the year. That's the great inequity, ultimately, right? And unfortunately, that's just not in our control. So if you do end up, you know, coming in earlier, if you'd been under the greedy system, like sure, the greedy system would have actually placed you slightly better, as you saw in the picture. But sort of, in a way, the kind of equitable thing is to treat everybody the same, irrespective of when they arrive in the course of the year. I think that's an okay thing to do. That's precisely what this algorithm is going to do. Yeah, that's all. Okay. All right, can I keep going? All right, so we're going to simulate a trajectory. As we like, imagine that we're God and we know who's going to arrive. Then what we can do is we basically solve the big problem, look at the Lagrange multipliers. That tells us exactly what the price, quote unquote, of each affiliate is. That is, how much extra employment would I get if I relax, if I given a bit more capacity to an affiliate. And then we're going to myopically maximize the employment scores minus this price of capacity that comes from the Lagrange multipliers. And then we thought we were really clever coming up with this. You know, this is a sort of like a pretty obvious way of doing it. It turns out that Alberto and Sid had already thought about this, and in fact, it fits into a beautiful class of algorithms for which they proved remarkable properties. So sometimes, you know, you think you're very clever, but of course, Sid has been there, you know, three years earlier. So how would the pricing approach work in our example? Well, what would happen is that essentially we would look at these two arrivals. Remember, this is our initial capacity, it was 5, but then we know that in fact Austin is very desirable. So that's what the simulating and then solving the model back, it would tell us, look, Austin's really great. We should downweight how much actual capacity there is in Austin, and it would actually be something like 2. So Austin is costly. It would then tell us that no, place this family in Austin, but place this family in Boston, right? And so that will work. So the question is, how well does this work? Turns out to work amazingly well, like scarily well, actually. So there must be reasons for why it works really quite that well. So it almost tracks the optimal hindsight. We are the purple line. That's Annie 2.0. And as I showed you already, this is our greedy line. This is the one we don't like. But look, we're tracking more or less perfectly what you would have done in optimal hindsight, right? Even though you're just kind of, you're really only estimating this. And why does this work so well? So if you look at priced capacity, right now, you know what priced capacity is. Look, you're basically using it up exactly linearly over the course of the year. It's kind of neat, okay? And this turns out to matter quite a bit. You're getting almost the optimal hindsight employment, somewhere between 89 and 99% of the optimal hindsight employment if you do it this way, okay? So the thing that I'm hiding here a little bit, and I want to very briefly mention, and this is why, in a way, this software is cool, because it doesn't actually take away all the human input. And it turns out to crucially rely on human input. And I'll just very quickly tell you how. So it turns out that, you know, as I showed you on the very first slide, how many refugees arrive in the US is a thing that can get changed like this, okay? And the thing to remember is that from a refugee's perspective, the year begins in October and ends in October. But your American administration changes in January, which is annoying because you're halfway through a year, you already start matching some refugees, and then some way through the year, a new president comes in and decides there's going to be a new amount of capacity, okay? And this can just change arbitrarily. So what I showed you here was a little bit unfair, because here I pretended like I knew exactly how many refugees are going to come. Now, if you trust the official announcements and just believe what the American government tells you, you're not going to do quite as well. Okay, so this is the point really on the slide, is that actually the official announcements are not kind of represent, so things change very rapidly, but also there's just kind of institutional lags in how many refugees can possibly arrive when you're putting in these constraints. Some people already have got their flights booked and so on. So what HIAS, the agency I work with, actually knows, they have a really good estimate of realistically how many people are going to come, given all the information that they have. And so what we had them do is we actually just looked through their records about their estimates of how many refugees they thought would come in. If you trusted the official announcements, if you just took the press releases from the White House, you would actually do really badly. In fact, our pricing-based rule in some years, this is 2017, yeah, you know what happened in 2017? You do really quite poorly, actually. So the algorithm wouldn't do very well at all. And the reason why it can happen is that sometimes in some years you have more arrivals than you expected, and your algorithm might do very badly. Why is that? Because you ended up with more arrivals, and then you haven't left yourself enough capacity. And so suddenly the last people that you're placing at the very end do extremely poorly. You can also have too few arrivals, right? This is what happened in 2018 in particular. We ended up with too few arrivals. So the algorithm really thought, oh, wait, we're going to have all these people still coming, but they're not going to be coming. So what we have the agency do is we have them give their own estimate of how many people they think are coming. And it turns out to be remarkably accurate. They can usually predict about 9 months ahead how many refugees are going to arrive. And that's a great thing. So Karen Monken here, who is the arrivals director, she basically keeps track on this number to make sure the algorithm always knows how many people are going to be arriving, whatever the White House might say. And she is the human input. You can't see her face, but she is right there. This is her using Annie Moore version number 1. And so just to show you how it's now implemented, what's cool about the new version in Annie 2.0, it's the same thing as you saw before. Blue boxes are the affiliates, and the differently colored boxes are actually now all the families are now colored in a slightly different color. And the reason is that we're trying to convey to Karen when she's doing this placement that you can't just take the family's employment probability today when you're placing a refugee. You've got to think, okay, how is this going to displace the future families that are coming in? So these different shades of green and red basically tell you what is the value of this match overall from a perspective of the whole year. You have a red match, it's basically not worth placing the family there because it's too costly to take up that capacity relative to how much employment you're actually getting. Okay, so it's kind of simple visual. All right, I have 5 minutes. Can I have 7 because I started late? No, I shouldn't because I just started late. It was my fault. Okay, so I want to tell you about the last thing. I have exactly 5 minutes to do it. I think I can manage. Okay, are we okay so far? Is the idea clear? We don't want to do static. We want to do dynamic, but really we're solving the same knapsack problem, but now over the course of the whole year. Some of these algorithms already turn out to exist, but I think difficult bit is really getting this implemented and making it work in the context that you're in, right? So it's not just as straightforward as taking Sid's beautiful algorithm and implementing it. Actually does require a little bit of art too. So this project I'm really excited about. It's alive. And in fact, any data I show you is probably already out of date because this thing is really happening at the moment. And this is an algorithm we've built specifically to relocate Ukrainian refugees. Okay, so the US promised to accept 100,000 Ukrainians. This is in addition to the 125,000 that Biden promised to take in. So these, sorry, this picture is quite hard to look at, but this is in addition to the 125,000 other refugees who are coming in. And so let me tell you about what the process for the Ukrainians is. It's a little bit different for how the rest of the refugees are resettled in the US. And the reason is the following. We've got our refugees there. They're Ukrainian nationals. They're typically at the moment somewhere in Eastern Europe, typically in Poland. So they have fled. The family composition is very different. Ukrainian men are not allowed to leave the country. So it's typically women and children. And what they do is they apply directly to HIAS. They do not apply to the US State Department. They go to HIAS and they say, I would like to be relocated to the United States. And they basically have to show the ability and willingness to relocate immediately. Okay, so we're going to try to match these people as quickly as we possibly can. And what we ask them to do, for the first time ever, we ask them where they want to go in the US, and we try to satisfy those preferences. Okay. This is in part addressing this issue that was brought up by a gentleman in the back, which was, well, why are we maximizing the strange objective? So as an economist, I sort of think, what you should do is maximize people's preferences, right? Now, we've got to make sure these preferences are actually kind of good and informed, but indeed, actually maximizing people's preference sounds like a very desirable thing for me to do. Now, we're going to match these refugees to sponsors. These sponsors are going to be families that are going to want to host these Ukrainian refugees in the US. These are just individuals all over the country, and they're going to be affiliated with kind of various NGOs. So in particular, they're going to be, they might be kind of members of HIAS, or be working with the synagogue that is part of the HIAS network. They're committed to supporting the family for 6 months. They put up a bunch of money to show that they can do it. The Ukrainian family does not live with them. They're merely being asked to help them find accommodation. And they applied to this specific visa, I-134. And it's at the moment, the processing times are between 1 and 2 weeks. If you know somebody who is interested in doing this, it can take as little as a couple of weeks if you find a sponsor to actually come to the US. It's extraordinary. It's very quick at the moment. Okay. Now, sponsors we then try to make sure we elicit a bunch of constraints. In particular, the sponsors tell us if they want to deal with difficult medical cases. Pets are really big. There's a lot of Ukrainian pets that are coming with these families, and whether they can handle large families. The largest family at the moment is big. It's still single digits, but it's a big single digit. Okay. And in particular, what they do is they try to inform the refugees about the places where they're from. So they provide these kind of nice descriptions. We really encourage them to sort of describe the area they're in and talk about the schools and the parks and all the good things that they have. Okay. So what the refugees are going to do, they're going to see all these profiles of these places and they basically rank as many of them as they want. And if they don't rank a particular place, that means they don't want to go there for sure. They would prefer to stay where they are. Okay, so you can rank as many places as you wish. So we have an algorithm to do it. I'm going to describe it to you because it's a beautiful algorithm. And we kept thinking about what it should be. And eventually I remembered this paper by Neil Thakral, who is currently visiting Princeton, but he's based at Brown. He is an economic theorist. And he came up with this algorithm when he was thinking about a problem of matching people to social housing. And we just took his algorithm with tiny modifications and applied it in practice. It's really elegant. Let me tell you how it works. So we have all refugees are ordered in a queue. There's a lot of them, right? And the sponsors are going to arrive infrequently. So the sponsor is going to come in, they're going to see this huge queue. And the question is, how are we going to, who we're going to match them to? So when the sponsor arrives, they will arrive into their own location. So this might be, you know, San Francisco, New York, Boston. So the sponsor arrives and they're in their own location and they will look at whether there are people queuing in that location. So I'll tell you how you end up in that location in a moment. But if there's somebody in the locations, you just match them straight away and then you're out, okay? But it's possible that you as a sponsor, you arrive in your location and that locational queue is empty, okay? So I'll show you exactly what's going to happen. But if the queue is empty, what we're going to do is we're going to go to the main queue. So at the moment you're thinking, how do I go from main queue to location queue? So I'll tell you that. So if the location queue for a sponsor is empty, we're going to offer this sponsor to the person who is highest in the main queue. Now that person has an interesting choice. They can either say, yes, I would like to be matched, or they say no. And if they say no, then they get to join any locational queue they wish. And we tell them roughly how long it might take you to wait for another match in a given locational queue that you pick. It's trying to elicit your preferences over time and in addition to your preferences over specific areas, okay? And so if this person said no, they just keep going to the next person. Eventually somebody accepts you, okay? So that's the idea. And it turns out this algorithm is efficient and strategy proof. It's gorgeous, it's beautiful, so elegant, right? It's exactly the setting that we have, okay? So this is what the interface looks like. It's already been built, it's operationalizing. And I want to tell you one cool fact, okay? Please allow me to have 1 minute. Now, one cool fact, this is the first data we just collected it this week. This is the first 30 people that have arrived. And I want to disabuse you of one notion. And the thing that I want to disabuse you of is that everyone wants to go to the same place, okay? Here's the amazing thing about these refugees' preferences. They're amazingly diverse. We've got like 30 families, that's all we've got so far. It's pretty small. Average family is, you know, reasonably big. The largest one is really big. And the first families that have been matched by our algorithm have already arrived to the US, okay? So just so you don't think this is just all in theory, this has already happened. So we've had a few matches, families are arriving. And so here is the coolest picture, I think. Here are all the locations that we have. And the different colored lines are number of refugees who've listed the place as their first choice. So let me just show you the two cool facts about this picture. The two most popular locations are LA and New York, okay? That's not a big surprise. But 50% of the people want to go to New York and the other 50% of the people want to go to LA. So you still don't really know who wants to go where, right? But look at what happens when you look at second preferences. You're going to be able to resettle everybody to New York. It's basically uniform. Okay, nobody wants to go to Newark and nobody wants to go to Sacramento, but it's like completely uniform. There's amazing diversity of preferences. And this is basically the kind of the key message. So the reason why you want to elicit these preferences is because they're actually really different. It really matters, right? What data you get when you ask people about where it is that they want to go. So I have all these various ways of how you can work on this stuff, which I don't want to do it. the one thing I do want to end on, I have an extra slide. If you enjoyed my talk and you want to praise me financially, don't do that to me. Please donate to this guy, okay? He's just trying to, he's fighting on the front. The winter is coming. They need warm clothes. If you want to donate, please donate to him. I've given you the GoFund page, but otherwise, thank you so much.
Thank you so much, Alex. Why don't we have one question while Swati sets up? At least someone who hasn't finished.
Hi. My question was, if families are joining only one location queue, it seems only the first preference matters for the matching.
You're very good. Now, here is what you're absolutely right. In fact, it doesn't even matter where the place gets ranked. When I come to you, I'm just saying, here is an offer to you, and you can just say yes or no. We still just say to them, rank us everything, because it gives us better data and a better, right? There's no reason to lie. So we're assuming these preferences are still, meaningful, but indeed, it actually doesn't matter. And in fact, what we're hoping, when more people start joining the locational queues, at the moment, people are just accepting matches because there's a lot of sponsors arriving. When this stops happening, we'll be able to actually compare their preferences with and without the waiting time. And I think that could be very useful data. It is true, we are just collecting this data for its own sake, but isn't it cool data, right?
It is definitely.
Okay, let's thank Alex again.
Cheers.
Our next speaker is Swati Gupta. Hello. Okay. Yeah, Swati is an assistant professor at Georgia Tech. In the interest of time, let's just get into her talk. She'll be talking about algorithms, law, and society.